just like what we had before for the previous 3 weeks, is about solving trigonometry equations. So that's very, very essential skills because it's going to be happening definitely in your real exam in June 2022. So here we have been given this equation: 2 cos of x plus 30 equals sine x minus 30. And they want us to show that it could be rewritten as tan x equals 3 square root of 3 minus 4, which firstly, one common mistake that people will do is divide through by cos of x plus 30, and we write that as tan of something. But it is not something that we could do here, unfortunately, because they are not the same argument. One of it is x minus 30, one of it is x plus 30. So that's why here, what we're going to do is using what we have learned in chapter 7 in A2, we're going to open up cos of x plus 30 and solve x minus 30 using compound angle formulas. So let me do it separately first. So cos of x plus 30 will be cos of x, cos of 30, take away sine x, sine 30. Whereas sine of x minus 30 will be sine x, cos 30, subtract cos x sine 30. Right, so here in our question, you could just put it in then. So you have 2 cos of x plus 30 equals sine of x minus 30 changes into 2 loss of x, cos of 30, subtract sine x sine 30 equals to sine x cos 30 minus cos x sine 30 degrees. Okay, now, so what we could do then is to rewrite cos of 30 sine 30 into exact values. The sine 30, if you use the calculator, it should be a half. Cos of 30 is square root of 3 over 2. So something that we should know this anyway. So 1 second, let me just get my page extender on. Now, so carry on. So we have, you just open up the brackets now with these numbers. So you will have 2 cos of x, cos of 30, minus 2 sine x sine 30 equals to sine x cos 30 degrees minus cos x sine 30 degrees. Okay, so whenever you have an equation that gets up to this format, so you would like to just have one ratio, tan, by just dividing through by cos. So here, actually, you don't need sine 30 cos 30. You could just divide every single term right here by cos x cos 30, every single one of it. Then let's see what's going to happen. So divide everything by cos x cos 30, and sine from the very first term on the left-hand side, 2 cos x cos 30 divided by cos x cos 30, then you will have just 2 minus 2 tan x and tan 30 degrees, and tan x and minus tan 30 degrees. And yeah, actually you just need tan 30, my bad. So tan 30 is 1 over square root of 3. Then just put it in now. So you have 2 minus 2 tan x multiplied by 1 over square root of 3 equals tan x minus 1 over square root of 3. Then we'll bring in the like terms one by one. So you have tan x plus 2 over root 3 tan x, and 2 plus 1 over root 3. And get rid of the fraction by multiplying through by root 3. So you have 2 root 3 plus 1 equals root 3 tan x plus 2 tan x. And then finally, just factor out the tan x, which you'll have root 3 plus 2, and then divide through by root 3 plus 2, and you get a number there. So I think in Castways, if you put that in, you will get the number in terms of root 3 straight away. But here, we'll just do a little practice. So in order to get the next step, you should just rationalize this. You could do either root 3 minus 2 or 2 minus root 3. Doesn't really make a big difference. So if you do that, you will have at the bottom, you have 3 minus 4, and on top, you have 2 times 3 minus 4 root 3 plus root 3 minus 2, which you'll have 4 minus 3 root 3 over minus 1, or 3 root 3 minus 4. That's 10x, which is what they have. Sorry, it's a little bit zoomed out, but this is what they have. So in short, the first step is very standardized. So you're going to use compound angle formulas. You just need to know when you picked up the equation which identity to use straight away. Sometimes you could just use AS identities, even in A2. However, very likely you'll be either using the reciprocal identities, sec square x equals tan square x plus 1, for instance, or these sort of compound angle formulas, or double angle identities. Now, here, you actually don't need that. So if you do this, it might be a bit more work because you will have some half and root 3 where it will make my head spin. So in order to proceed, after you open up brackets on the left hand side, just simply divide through by cos x and cos 30 for both the argument of x and the one that you know, the angle of 30 degrees. By doing that, then you just have a really nice expression to work with, just in terms of tan, where you know tan 30 is 1 over root 3. And even if you prefer, you could just leave it in tan 30 first, and we arranged here, and it will be the same thing, but let's just do it one more time and see if you like it this way better. So we arrange from here, so 2 plus tan 30 and tan x plus 2 tan x tan 30 degrees, and you factor out the tan x, where you have 1 plus 2 tan 30, bracket out tan x, where if you like this more, then yeah, you will have 2 plus tan 30 all divided by 1 plus 2 tan 30 first, and then yeah, and then you could rewrite, you could substitute tan x now, which you'll get 1 over root 3, and you'll get to this step right here. Okay, so see which way you like better, and but ultimately you'll get to the same answer, just 3 root 3 minus 4. All right. Okay, so now that is part A, and now part B. So hand or otherwise, which will use will use hands very likely, which means I need to make good use of what we see from part A to solve this equation. Okay, so let's spot the pattern. So still 2 loss of cos equals sine of something, and the argument is slightly different. So we have 2 theta plus 40 against x plus 30, and 2 theta minus 20 against x minus 30. So I need to know how I could make good use of the identity above by looking at how I could make a connection between x plus 30 and 2 theta plus 40. All right. So ultimately, because the formula is just in terms of x, isn't it? So that's why I need to make a connection between x and theta here. So I could just solve the ones in purple. So x plus 30 should be, in order to utilize the identity, should be equals to 2 theta plus 40 degrees, which means x is 2 theta plus 10. So I could double check this by looking at the one in green. So this is the purple, and now let's check green to ensure that we could use identity by just replacing x with 2 theta plus 10. So we have 2 theta minus 20 degrees equals x minus 30 degrees. And if you make x a subject, again, you will have, which means you add 30 degrees on both sides, you have 2 theta plus 10, which confirms that actually, if I want to use this identity where I could rewrite this into 10x equals 3 root 3 minus 4. I will make x as 2 theta plus 10 for this specific case. All right, so this is how I could use the identity above. So let's use it for the next part. So I could then immediately rewrite this as tan of 2 theta plus 10 degrees equals to 3 root 3 minus 4. Okay, now again, at this point, you would not like to open it up again using compound formulas. You would like to just just do tan inverse. This is just like the equations that we have been solving since AS. So you could just keep the 2 theta plus 10 degrees and you do tan inverse here of 3 square root of 3 minus 4 and make it equal to 2 theta plus 10. And you'll be searching all the answers, all the possibilities here against this interval. We're starting from in between 0 to 180 degrees for theta. So if you do that for 2 theta plus 10, then you need to change the interval for it. So therefore, you double that first to 0 to 360. If you add 10, then I need all the answers from 0 to 370 degrees. Okay, so then let's just do that. So we'll have, let's go to manual and then you just find all the answers. So make sure that it is in degrees every time when you are using no matter which calculator. So this time it has to be in degrees. So I've done that. So let's just exit and let's do this. So I'll have tan inverse of 3 square root of 3. So shift square root of 3 subtract 4. So let me add a bracket there just to ensure that we are doing tan inverse of the whole thing. So we got 50.1 degrees for the first answer. Let me just write this down. Oops, 50.1 degrees. We're not using this answer, but I'm just writing this down here. And then we're just going to do, to get the alternate answer, we're just going to do 180 adding on to these answers. So let me save this as A first. So that will be A. Oops, exit. Yeah, so let me just do answer and store it to A. Okay, and then so I'll do 180 plus A. Sorry about that. I was just getting used to this calculator sometimes too. And the second one you get should be 230.1 degrees, and then essentially just adding on 180 until you get to the other answers. So you keep on adding 180. So if you add 180 to this one, you'll have 510, which fills up the space that we have. So that will be 410, but then that will go beyond what we have. Okay, so we're just going to subtract 180 to check on this one, where you have minus 130. So no, you don't need those answers. So you just need these two, and you make theta the subject. So you have 2 theta plus 10 degrees equals to 50.1, that answer, and 2 theta plus 10 degrees equals to 230.1 answer. Then you just rearrange for theta. All right, okay, so let me store this answer as B. Did that. Okay, so I just rearrange for both. So in order to rearrange for these two answers here, I'm going to subtract 10 for each answer and divide by 2. So I'm just going to do that for this. I will just do the rearrangement for this one. On the calculator, I'm just going to do fraction A minus 10 divided by 2, which you'll get 20.05. So right to one decimal place, that will give you 20.1 degrees. Okay, and the other one, so you do the same thing. So you will go to the calculator and get to just a fraction. Do the same thing. B subtract 10 and divide this through by 2, and you get the answer of 110.1 degrees. Good. So make sure to use the store function in the calculator, so it could help you to find the answers in a better way. Okay, so just to recall what we've done in question one. In question one, we have used the compound angle identity to get to here, but in the middle, in terms of the simplification perspective, so we'll divide through by sine cos x and cos 30. So instead of dealing with all the mixture of cos and sine for each four terms, then you could just stick with just tan x and tan 30 once you have done this. And that will be way easier in terms of the rearrangement in the second half of the show that part. Okay, and then part B is quite a difficult application here, because in order to spot x in terms of theta, it's not as straightforward as the others are, where in this case you need to actually equate these two and see what we should put as x in terms of theta. And once you get to this stage, you have to be careful with not open this up using compound angle formula. It's not necessary because it's already all in terms of 10. It's just 10 of something equals a number. So that's why you could just solve it easily by applying tan inverse. You get two alternate answers and you make theta as a subject. Okay? And make use of the store value function too. All right? Good. This is question one. And then here comes question two, where we start by looking at the differentiation in A2, because it's something that we have been learning in maths lessons right now. So the first one, I would like to differentiate 5x squared multiplied by ln of 3x. Okay, so in order to differentiate this, there's two rules that I will be aware of, or I need to use. So as a whole, I need to use product rule because there are two expressions, two functions, 5x squared and ln of 3x. However, when I differentiate ln 3x itself, that will be chain rule. Okay, so these are the two rules that I need to be aware of when I'm doing this. So I'll do this step by step. So in terms of the product rule, so that will be I'll call one as U and name another one as V. And I'm going to differentiate these two. So if I differentiate U, it should be all right, just tan x. Now when I differentiate V with respect to x, so I need to use chain rule. So my practice will be I'll differentiate what is inside the bracket first. If I differentiate 3x, I'll get 3. Then when I differentiate the outside, which will be ln of the bracket, so that will be 1 over the bracket, and then I'll just rewrite what's inside, which is 3x, so that cancels out nicely to 1 over x. Okay, so just a note here, when I'm differentiate ln 3x or ln kx in general, the reason why I will always get just 1 over x will be we could explain it using logarithm rules too. So ln 2x, I could rewrite this using logarithm rules. That would be ln 2 plus ln x, where we are always very good at going backwards from here, combining logarithms, but not necessarily the other way around when we're trying to expand this. Okay, so going backwards. So actually ln of 2x, if you rewrite as a several logarithm terms, it could be ln 2 plus ln x. That's why when I differentiate this, ln 2 is a constant. If you don't believe me, then we could just go to the calculator. So that will be ln of 2. So ln2 is a constant 0.693. So when I differentiate 0.693 with respect to x, it has to be 0. And then ln x itself is 1 over x. So that's why if you differentiate any ln expression that looks like this, you'll always get 1 over x. Okay, so this is the chain rule here that I've done, and this is the preparation of the product rule. So I'm just going to use this. So if I'm differentiate a product rule, this is the formula. So it's uv dash plus u dash v. So I'm just going to put this in. I will have our final answer when I'm differentiating that. It will give me u first, 5x squared multiplied by v dash 1 over x plus 10 over x, 10x times ln of 3x, which I'll get 5x plus 10x ln 3x. Okay, so that could be the final answer. Or if you like to do it slightly more fancy, then you could take out what they have in common, 5x and 1 plus 2 ln of 3x. Or you could even rewrite this as 5x, bring the 2 up, 1 plus ln of 3x all squared, and you have 5x, 1 plus ln of 9x squared. But if you have done up to here, you're fine. Okay? The rest are just for your for just fancy algebras. Okay? Any questions for yeah, so that would be for 1. I forgot I'm just talking to myself. Sorry. Now, so this is part 1. Now, part 2. Okay, so I'm going to differentiate that with respect to x. Now, this is a there are algebras and there are expressions in terms of x on both top and bottom. So that's why you're going to use something called the quotient rule. So I'm going to state the quotient rule first. So that will be y equals u over v. That implies when I differentiate that with respect to x, that will be v squared v times u dash minus v dash u. Okay, so that's why let me do all the preparations first. So u is sine x, u is x, and v is sine x plus cos x. So I will have u dash as 1, v dash as cos x minus sine x. Okay, and then we sort of need to cross multiply, but it's going to be v dash vu dash subtract uv dash on the numerator. So let's just plug these in. So we will have dy by dx as v squared, so sine x plus cos x all squared, and we have bu dash, so sine x plus cos x multiplied by 1, subtract x times cos x minus sine x. Okay. Now notice that what we have so far, which we have done it correctly according to the quotient rule, does not match with what we have on top. Okay, so in the denominator, they want 1 plus sine of 2x, whereas R1 is a square form. And then on the top, we have the factorization done for sine x and cos x, where this is all over the place so far. So that's why we need to move on. We need to carry on and starting from the bottom first in order to get 1 plus sine 2x eventually. So let me just write down the target here, 1 over sine 2x. What I need is to open up the brackets and see what's going to happen next. So we have sine square of x plus 2 sine x cos x plus cos squared x. Okay, so I'm just going to focus on the bottom right now. And then notice that, therefore, you could see why it changes into 1 plus sine 2x, because that adds up to be 1, and this is just sine 2x. Okay, so therefore, you could just rewrite this as 1 plus sine 2x straight away, okay? Because that is pretty much implied. So that is not much skills terms that steps that you need to show here. Now on the top, so let's see what they need. On the top, they need 1 plus x sine x, bracket sine x, and bracket 1 minus x cos x, I believe. Okay, so here what you could do really is just to open up the brackets and to collect the like terms. So for the second one, just be mindful. So it should be minus x cos x plus x sine x. Okay, and then you could just take out what they have in common. Let me just write one step together with 1 plus sine 2x. That would be sine x plus x sine x. Well, I collect like terms first. Plus cos x minus x cos x. Okay, so that's why I will have, if you take out what they have in common for the first one, sine x, then you'll have 1 plus x in common, and you have cos x, then bracket 1 minus x in common. So that's why this is what you'll have as the final answer. Okay, so two things. So in part A, so as a brief summary what we have done, so it will be, yeah, so in lessons, hopefully you could see where all the rules will be in play, even when we're just doing product rule. Okay, so that's why chain rule is always in play when you are in different situations. So for instance, if for the second question, instead of sine x plus cos x, they have sine 2x plus cos x, then yes, in part two, when you're doing the differentiation, then that will be changed into 2 sine x cos x for the first term, subtract sine x, where you need to be mindful of the chain. Again, distance expression like a minus 2 or anything like that. So if I take moments at A, there are 4 forces here, and they all contribute to the moment equation because they're not exactly at point A. So let's do the ones at clockwise first. That will be 140 and 30. So that will be 140 multiplied by the distance of A, because that is the weight of the rod. And since it's uniform, so that has to be halfway through. And the 30 multiplied by distance of 2A, because it's at the other end of the rod. And then the rest, it will be 50 multiplied by 2, with the distance measured from A. And the distance AD of 6, again given. So we just add it on to 120 times 6. So on the left-hand side, you have 140A plus 60A. That will give you 200A. You have 100 plus 720. So 200 of A plus 820 equals to 820. So you have A equals to 4.1. All right. So that will be part A. Now for part B, they say the support D is now moved to E, and it still remains in equilibrium despite nothing else changes. So when you have been working with a system like this, despite they just shift the support by 1 notch or something, you still need to recalculate all the reaction forces. So you can't use the information here anymore, because that only caters when D is exactly 6 meters away from A. So now you can't just then follow with this sentence here and conclude that the support force at both pivot will be 120. So this is something that you are not supposed to do. So therefore, whenever you have been introduced to a new system, you have to draw an entire new diagram. So we'll have RC here. Let's call this RE. And this time we don't know this distance. So we'll call this distance X. Okay, and then we have the weight still halfway through because it's still a uniform rod. So the distance that we got before is 4.1. So let me just double check the answer first. It is 4.1. So yes, we could just halve this. So that would be 4.1 divided by 2, and whatever that is. And then we have a weight here, which is exactly 4.1 away from point A. Now, um, so in this situation, the amount of unknowns increase. There are 3 in total. But fortunately, because they tell us the relationship between the reaction forces, so again, I will straight away just go and find the forces first by simply doing up equals down. So you have RC plus RE equals to 140 plus 30. And since they're the same, so basically you have 2RC equals 170, which means RC, or the reaction force at either support, will be 85 newtons. Okay, and once you have that, then you could just consider moments, and really. And again, I was just going to consider moments at point A. So let me just take moments at point A, and it's pretty much what we have done just now, and just we don't know distance x. So again, 140 and 30 will generate the anti-clockwise moments. So that will be 140 multiplied by the distance of 4.1 divided by 2 plus 30 multiplied by 4.1 equals to 85 multiplied by the distance of 2. That never changed. Equals, sorry, not equals, plus 85 times x this time. So let's just toss that into a calculator and see what numbers that we get. With 140 multiplied by 4.1 divided by 2 plus 30 multiplied by 4.1. That gives me this number, 410, and this is 170 again. Just a coincidence, I guess. So subtract 140 and divide by 70 to get the final answer. So answer, subtract 170 and divide this by 85. So x will be 2.8. And you just need to round to 2 significant figures. So that will be question 4 for you. So as a general reminder, what you really want to know when you go from A to B is how the system has changed. I need to recalculate all the reaction forces. And that is really the only thing that will throw people off. Question 5 is a bonus question, and the question that I picked this week is a little bit weird. But that was the reason why I select this one, because I want to challenge you guys to think a bit more conceptually, and this is also a good question to assess your concepts across different topics. So I'm going to start with question A, part 2. So I assume that part A1 will be fine. Just differentiating the cubic function with respect to x1s. And you get 3x squared plus 2bx plus c. Now, secondly, then they say, hence, given that f inverse, the inverse of this cubic function does not exist, show that b squared minus 3ac squared is 0, where a, b, c are the coefficients. Okay, so let's just do some examples first and come back to this. So for instance, if I have the function that looks like that, so x bracket x plus 1, x minus 1, where this will be a form of this cubic function. If you open this up, it will give you x cubed minus x. So the curve looks like this, where it goes through minus 1, 0, and 1, and this is a happy ending. And another one, which is minus x cubed, and your graph will sort of looks like this. Okay, so the one on the left, the function exists, but its inverse does not exist. Whereas the one on the right, the inverse does exist. It's not because it is easier to rearrange. It's just that because the function on the left, it is a many-to-one function, whereas this function here, is what we call a one-to-one function. What do we mean by many-to-one function? It is when you just draw a line horizontally where you could see that it crossed the curve several times, meaning there will be a several values of x that gives you the same value of y. Or even if you put this line on the x-axis, it makes sense. There will be many x minus 1, 0, and 1 gives you the same value of y of 0. So that's why we call this a many-to-one function, since there's many x gives you the same y, whereas the function on the right, it never repeats. Okay, where one unique x just gives you one unique y. Okay, and so this one, let me just label it down first. A f inverse does not exist, and the one on the right, f inverse exists. Okay, and then now if you notice the shape of the curve, not only be it happy or sad, and happy or sad, then if I change this one into happy, where it will looks like this. Okay, so the differences between the one on the left and the right is not only the one on the right is slightly taller, it is where there are stationary points on the one before on the left. Okay, so you could see if I have a graph that will not have f inverse, you could see there will be chunks of stationary points, whereas the one on the right, these turning points never exist. It's as if this is just a smooth action. Okay, so that's why in order to answer this question, we could attack this problem using this perspective, actually using the stationary points. Okay, so recall, how could we find the stationary points here? I could just find a gradient function and set it equal to 0. So that's why they say the word hence for A2, because I'm just going to use the gradient function, okay, for this incident. So I could just imagine myself finding the stationary point. So I'm just going to set my gradient function as 0, okay, indicating that I'm trying to find finding these points. And since I'm at this situation where f inverse does not exist, that means I must have answers for stationary points. That's why I'm going to set the b squared minus 4ac for this quadratic equation greater than 0, because I have answers for the stationary points. So that's why when I'm solving this gradient equation, which ends up to a quadratic equation, there must be answers. So that's why I'll do 2b bracket squared minus 4 bracket 3a bracket c, and it will be greater than 0. Okay, so that's why that will be 4b squared minus 12ac greater than 0, and b squared minus 3ac bigger than 0. So that will be the condition for my function to have no f inverse. Okay, because that means I must have turn. So therefore, the turning points to start with, but it's actually really called stationary points, for it to have this phenomenon. Hence, your function will never be one-to-one. So if I'm doing this on the other hand, okay, the one on the right, so for the one-to-one function to exist, therefore you could see there's no stationary points at all. Therefore, if I'm at this point solving this equation, where I'm attempting to find stationary points, and for the one on the right, you could see there's no stationary points, and hence I'll be solving b squared minus 4ac less than 0, and you'll have the opposite result, where you have b squared minus 3ac is less than 0, for you to have this sort of shape, and hence the f inverse exists. So that is part A. Now moving on to part B. So a question for part B, this time they asked us to consider this cubic equation, which means there are sign values for A across D. And they asked us to firstly show that G inverse exists. So you could just make use of this inequality that we have developed. So you could just substitute B, A, and C. So therefore, minus 3 squared minus 3 times a half times 6. You work out this number, which is 9 subtract 9. That equals to 0. So that means, yes, that will be inverse, because if you just have one stationary point, that's fine. Okay? So you will still have the inverse, because it's not the case where it's greater than 0. So you will have inverse even for this case. So now they want us to put into this form, okay, where we could find P and Q. Okay, so how can I find P and Q quickly in this case, where you could pretty much just open this up, okay, because we know that x minus 2 cubed will be, you could just expand it with a cubic expansion, so that'll be x cubed plus 3 bracket x squared times minus 2. Um, Let me put a square bracket for p, and we have plus 3x and minus 2 squared plus minus 2 cubed plus q, where you have px cubed minus 6px squared plus 12px minus 8p plus q. Okay, so therefore what you could do really to find p and q is to just compare coefficient, and then you get the answer. Okay, so actually you just need the constant term, and you just need to cube the coefficient of x cubed. So you have p as a half, and you have minus 8p plus q equals to minus 8, and therefore you have q as minus 4. Okay, so therefore they have put it into that form for us already, where like a complete the cube form, you could say here. So p will be from what we have, a half, and qs minus 4. So why is that helpful? Because then it will help us to just find g inverse very easily. So therefore g of x could be rewritten as a half of x minus 2 cubed minus 4. So if you want to find a g inverse, then really what you're going to do is just to just make x a subject here from this instant. So we just do y plus 4 equals a half x minus 2 cubed, and 2y plus 8 equals x minus 2 cubed. You cube root both sides, and then you will just have x equals 2 plus cube root of 2y plus 8, or you have f inverse of x equals to 2 plus cube root of 2x plus 8. Okay, so that will be the g inverse in this case. Now, and finally, part C, they ask us to describe the transformation that we apply to go to from F to G. Okay, so we could just describe it step by step. Okay, so that will be a multi-step transformation. So we get from x cubed to a half of x minus 2 cubed minus 4. Okay, so the numbers on the outside, they will be influencing the y, and the numbers on the inside will just be impacting the x. So what you're really just going to describe will be the transformation of x and y. So you could just describe using a vector first. So that will be a transformation of 2, then minus 4. So you move across by right by 2, and then down by 4. And then you say you stretch with a scale factor of a half parallel to the y-axis. Okay, so that will give you the graph that we need. And now finally they ask us to sketch it on the axis. Then this part we could just omit it for now, because in their syllabus they could just draw it very easily using CG50. Okay, question 3, a probability question. So just one sentence. Consider the independent events A and B, given that probability of B is 2 lots of probability of A and probability of A union B is 0.52, find probability of B. Okay, so let's start with this sentence first. If it's independent, that would mean I'll have probability of A intersect B equals probability of A times probability of B. Okay, how does that help me to solve probability of B? So from here, you need to learn probability formula from 2.4. So if you haven't done this yet, so feel free to skip it first for this week. And so once you have learned 2.4 with your class teacher, then you could come back and try this question. So the formula is as follows, which is probability of A union B is probability of A plus probability of B minus probability of A intersects B. Okay, and then we could throw everything that we know inside first and see how does that help us to find probability of B. We have 0.52 equals to probability of A plus probability of B, and we know probability of A intersect B is just probability of A multiplied by probability of B. And since I'm just interested in probability of B, so I could get rid of all these if I just use this relationship here, where probability of B is 2 lots of probability of A, which means probability of A is just half of probability of B. All right, so you could just substitute it in for these two positions. So you have probability of B divided by 2 plus probability of B minus probability of B over 2 times probability of B. And you will have 3 over 2 probability of B minus probability of B all squared divided by 2 equal 0.52. So if you look closely, this is just a quadratic equation. So it will be easier to see that if you just make x equals probability of B, where you're going to have 0.52 equals 3 over 2 x minus x squared divided by 2, or 1.04 equals 3x minus x squared. So we have x squared minus 3x plus 1.04. Okay. So with that, then we could solve this equation. So we'll have just solvent. So we have option and then go to cal and then solvent. So we have x squared minus 3x plus 1.04 and make it equals to 0. Okay, and then you get these two answers. So you have P, probability of B, which is now x, is either 2 over 5 or 13 over 5. And since this is a probability, so 13 over 5 is of the consideration, so it's just 2 over 5. That's the final answer.